Hello, welcome to Module 3, Chapter 3, Tape Measurements. Uh, Tape measurements are something that surveyors do not do a lot of anymore. However, they're very helpful and very useful when they're still done correctly in the right application. When I first started surveying, I would do a lot of construction stakeout, and this was in the late 1980s, mid 1980s. I would use a lot of chaining and taping to do construction stakeout. Uh, when you have three people, a lot of times it was faster to chain certain things than it was to shoot them with an instrument. So there was a lot of times we would use for various purposes, whether it's for staking out a road, whether it was for you know, concrete construction. I've even used it steel tape to stake out a building. Um, so it can be done. A lot of times we would use them for utilities, storm parking lots. It was often easier to tape things faster than it was to use a conventional instrument. Some of that is gone now. Most of that is gone, but taping is still very important for the construction industry, and especially as a construction manager, where you may not have the best survey equipment, understanding how to use a steel tape or cloth tape, fiberglass tape, would be advantageous to you in your career. So I'm going to go through the PowerPoint presentation. You can download the PowerPoint slides yourself, and I'm going to not necessarily read them, but I will talk over them. So let's get share here. And there you have it. So we have the screen share going. All right, so tape measurements, chapter 3. We have different techniques for measuring distances. And I already mentioned a couple of these, the steel tape and the fiberglass tape. Also electronic distance measurements. The book says we'll talk about that in chapter 5. The pacing and a measuring wheel are all things that I use in the survey world. I don't have a tape anymore. This one down here, I don't have that anymore. It's not as necessary for the type of work that I do, but every job I go out to, I pace. I don't use an odometer or a measuring wheel, but I know many people that do. Use electronic distance measurement every day I'm surveying. And many times I will use a fiberglass tape to measure something. So what are they for? The book does a fair job of explaining some of this, but pacing is simply to get you in the idea of where something is. You know, most people's paces are 2.5 to 3 feet long. Me, mine are 3 feet long. So I know that in 50 feet, I can take 17 steps, and I'm around 50, 51 feet. So that's the type of thing that it's for. It's just to get you a good idea of where something is or how far away something is and go take a look for it. So pacing still has a good application. Pacing is refined with a measuring wheel. The only difference with the measuring wheel is you got to have one, and it's another piece of equipment. You're given the 2 feet and the legs to pace with. So they both basically would do the same thing. Very few people would take a survey grade measurement with a wheel. It's just not a good idea, and it doesn't work very well. The electronic distance they're shot with total stations now. We've had a little bit discussions about total stations. We're going to talk a lot more about that in chapter 5. And of course, a fiberglass tape is exactly what it says. It's many of you probably seen a metal tape that's used for carpentry. Maybe a cloth tape that's used for sewing, and a fiberglass one is in between. It has strips of copper coated with fiberglass, which looks a little bit more like cloth tape, and printed very well and legibly and very easy to read and use and very lightweight. The steel tapes were very accurate and very good and it's just not something that is used as much anymore, but it works the same as any other type of measuring tape. So those are the types of measurements or the tools that you would use. We're not really going to deal too much. I'm not going to ask you much about the steel tape, the graduations, or the cut tapes and add tapes. Basically, let me see what this one here is. This is an add tape. All right, if you notice this, I'm not going to be able to zoom in too much here. No, yeah, I can. I get it. Okay, you see this says like 100 feet, and then it has extra information beyond it. This is an add tape. In other words, you would pull the distance, you'd measure a distance, and somebody would hold like on the even foot mark, and then you could read the extra down here to get you how much further it is. Say like, 50 feet, 6 inches, or 50 feet, 0.5 and 5/10 of a foot. You'd have this extra that you're looking at beyond, the even foot mark. So a lot of tapes are measured directly. Some of them were like this. You'd hold it, and the tapes I saw had no intermediate graduations like this. So today you're not going to see too many of those. The book makes reference to it. I don't think I asked you anything about it. Zoom back out. You can see here various steel tapes. They're hundredths of a foot. You can buy fiberglass tapes that are done the same way. They're marked in hundredths of a foot, or you can buy them in inches. Surveyors work in hundredths of a foot, if you haven't figured that out by now. And the reason for that is it's easier than fractions. That is the main reason. It's simpler than fractions. Let's see here. Taping accessories, chaining accessories. All right. If you're going to use a steel chain, you need a tension handler. If any of you have seen a fence, they have tensioners that pull the wire, that pull the barbed wire and make it tight. If you're working on a car, you have if you want to take off your fan belt or your serpentine belt, there's a tensioner, a belt tensioner that pulls the belt tight. The same thing with a steel tape. If we want to accurate, we have to pull the tape at a certain tension, and that would be taken into account with this tension handler. A lot of them, they actually had a little gauge on them to tell you how many pounds per foot you're pulling. Range pulls are not something that we're going to talk much about. A clinometer is something that measures your slope in percentages. A hand level is literally something that you look at. It has a little bubble inside. One of my videos that I found for you has a demonstration of a hand level. And so you look through the hand level, you see a little bubble, and it tells you what is at what's level at eye level. And the plumb bob is something that we definitely want to draw attention to. The plumb bob is this shape, and somewhere there's going to be a picture of one, but it's this trapezoidal triangular shape. It's a cone with a string on the end of it. And that always falls plumb to the center of gravity. So it makes this string a very taut, straight line for you to measure with. Plumb bobs are used by carpenters to literally check to see if a wall is truly vertical or not, or the word is out of plumb for something that would be crooked or tilting one way or another. This is a hand level. It's an old style one, but some people call them lock levels. But this right here enabled you see this on the inside, and enabled you to look through something. As you tilted it up and down, you would find out when you were level, and then you would be able to read a location on a person's body or somewhere else that said, hey, this is level with my eye on that person or that stake or stick or anything like that. So they're fair. Not a lot of people have them anymore, but you see more of these being used in construction management and construction companies than you do by surveyors. And this is the application of it. You want to be able to measure horizontal distance. And so you would use this, you'd use this right here, this hand level, and you notice, hey, at my eyes, I'm level with your knee. And so you would now know that we could measure a distance right here, and it would be pretty close to a true horizontal distance. All right, now this is I believe this is a graduated, it's a hand, it's not something that's used very often. I've never used anything like it. This book has some old pictures of equipment in it, but this right here will help you, like, you can look at an angle. So you'd be able to tilt this thing if you wanted to look downhill at a 2-degree angle, a 5-degree angle, you could do that. Or if you want uphill at a certain slope, you could do it that way too. Just by adjusting this right here, this way or this way, it would let you know when you're looking up or down and perfectly straight. So, but I don't see too many of those anymore. This type of, if you're trying to get over top of something, figure something out and the height, that's what it was talking about, using the hand level. People just don't do that too often. I have had a field crew use a clinometer, which measured slope and height and was able to we actually were able to utilize it to measure height of trees at the St. Mary's County Airport. Trees over a certain height were coming down. So we had the job once of getting every single tree and getting a height, putting the tag on it so that somebody could determine whether or not it had to come down. This type of diagram is something that you would really do in life. You wouldn't really do it though with the hand level and the tape. You would use something like this with a stadia rod, which we're going to talk about in chapter 4 more than here, but it is something that you would actually do. This is how you would horizontally tape something. So if you want to know the distance from A to D, you want to know a horizontal distance. The way you would do it is you'd pull this tape and you hang the plumb bob, you use your hand level to make sure you're level, and then from that spot, wherever you're level, you would drop your plumb bob over the point and you get the distance. And then the same thing here, this one shows it being supported on the ground. And then here again, we were using the hand level to get a level location and measure from there. That's how you actually measure something and get the horizontal distance from A to D even though the land is dropping and rolling and back up again. So that is a perfectly good technique. You could still do the same thing today. And if you're trying to do something like find a property corner in your yard, this type of measurement would help you, just for understanding that you need to stay level. Here's a situation where if you just hold the tape high enough and both people have a plumb bob, you could get over this hump like that and not have to worry about it. You always want to get a horizontal distance. Surveyors rarely ever use slope distances. They have been used in the past on mountainous terrain. Even here in Maryland, out in Western Maryland, Garrett County, but not any longer. Now everything is done horizontally, but you may encounter slope distances if you're ever buying property or doing work in the mountains. The book talks about steel tapes and does a little bit of lecturing here on a steel tape. Keep in mind that steel is affected by temperature and by tension. So if something is hot, steel can pull it further apart. If something is cold, you can't pull it apart, and it shrinks. So it changes the actual measurement of the temperature does, and so does barometric pressure to some degree. There is a lengthy formula called a chaining formula to fix and correct all the different things that go wrong with taping. It is not something you have to worry about if you just pull it fairly tight. Make sure you're level, you'll get a pretty good answer. Now, one of the things that, like I said, that's a steel tape. Not a lot of people use steel tapes anymore. But what I do want you to understand, whoops, I went too far. I do want you to understand that when you're using a steel tape or even a fiberglass tape, you have these type of errors involved all the time. You can't measure on a slope. You got to try to stay level. What if your tape measure is broken? I have one that's missing the first 2 feet. Sounds silly, huh? You're missing the first 2 feet. Well, it was a tape that I found that was 300 feet long. You don't find many of them 300 feet long, and every now and then I have a shopping center or somewhere where I need to measure something that's over 200 feet, and I'll use my cloth tape. So I have to remember I'm missing 2 feet. I have an erroneous length when I read. The other thing, temperature doesn't come into play too much with the fiberglass or cloth tapes. Tension and sag do. You've got to be able to pull that tape tight and get the sag out of it, or else you're getting a bad reading. So that's something that is relatively important. Random taping errors again. Same problem here, slope, temperature is just showing you the same type of things we just discussed. Couple of these things here on the bottom, alignment, marking, and plumbing. Sometimes, let's say you had a 50-foot tape and you needed to measure 5 feet. You'd have an alignment problem possibly, in that maybe you're not measuring straight. You're gonna have to go from A to B, which you know is 75 feet, but you can only go 50. So you have to stay straight between A and B while you measure the first 50 feet. Then you would mark that spot on the ground, and you use your plumb bob on both ends of everything to make sure you're going straight and keeping things level. So these come into factors with even whether it's steel or fiberglass tapes. Again, here is some of your possible errors. I didn't ask you anything about that. There's no reason to ask you about things that we don't really take into account or do anymore. Excuse me. This right here is really, it's just a way of measuring, checking distances, front and back, getting averages, so that you have an idea that you're doing repeat measurements to get something correct. You would not do this either anymore. This is not something that you would need to do, or something that I've ever done as a surveyor. It's just not necessary anymore. One of the things that I want to point out, and I'll stop my screen sharing. One of the things I want to point out is that in your book is a type of chain that's discussed. Let me find it here. Let's see. It's in 3.2. It's called a Gunter's chain. I have a little video on it, and I asked you a couple questions. I just want you to understand what a Gunter's chain is and how important the measurement it is. We don't use a Gunter's chain anymore. I used one once at a conference where I learned how inaccurate, and they could be as precise as they wanted, but how old surveys, from from a period of time, probably from the 1950s all the way back to the days of George Washington, how they were inaccurate with these Gunter's chains. But a Gunter's chain is 66 feet. It is made up of 100 links. We have other measurements that are given to you here in chapter 3.2. A rod is 16.5 feet or 25 links. 80 chains is 1 mile, and 10 square chains is 1 acre. So they even have, there's other measurements that fall into place. Railroad tracks generally have a 66-foot wide right-of-way. Not necessarily nowadays. We know, say, like the Metro or Amtrak, but surveyors would use a 66-foot chain to lay out railroad right-of-ways that were for older purposes. But even now, those right-of-ways for, carrying, like the train that runs through Charles County down to Chalk Point or over to Morgantown, those right-of-ways are generally 66 feet wide. The train that used to run to Lexington Park, to the base of Lexington Park, that also was 66 feet wide. The train that ran out to Indian Head, now in Charles County, it's the trail, the bike trail, rail trail they call it, that was 66 feet wide. So the 66 feet is interesting. It comes into play with a lot of our base measurements. It's also something that you'll pick up in an old deed. You're never going to have to use it in construction, but if you buy an old piece of property, you may see chains and rods and links in that deed, and I don't want you to be scared of it, so to speak. So you can read the chapter. It's not very difficult on taping, and it talks about, the things that we've already discussed. And then I have a handful of questions for you at the end of chapter 3. So I'll take a break and we'll be right back with chapter 4.